Personalize ChatGPT on your documents using LangChain. Hey everyone, this is KeyStrokes. Welcome back to the channel. I'm a senior software engineer at one of the FANGs, and I like to make videos on anything and everything about computer science, like ChatGPT, AI, ML, interview tips, lead code, and basically anything and everything about computer science. Today, we'll take a look at how to use ChatGPT and personalize it to get answers on your own documents. Since ChatGPT was introduced, it has changed the AI ML world. It has given a big push on improving ML and AI services and has made it very easy for anyone to use machine learning and add more intelligence to their applications. So ChatGPT is just awesome. It works really great as a general purpose assistant where you can ask any questions to it, and if you do your prompt engineering right, you can almost always get the right answer that you were looking for. And it basically uses all the information from the internet that it was trained on. And it wasn't surprising when people realized that there's a need to somehow personalize ChatGPT so that it can work on their own documents and their own knowledge base, basically limiting the answers to some specific documents or knowledge base which the user provides rather than using the whole internet. And that's what we'll try to solve today and see how we can build an application where you can ask a question and get answers based on the documents that you provide to ChatGPT. And this is how the application will look like. We will make various topics available, like here we can see we have cardiac surgery, Ethereum white paper, medical flashcards, React documentation, and even Wizard of Oz. And then we can have a chat-like UI where we can ask questions on the topics that interests us. And while I was working on this project, I was using React, and I was wondering how do I turn off autocomplete on an input field. I almost went to Google, but then I thought, let's try to use the application and see how well it works. And as you can see on the screen, it did not disappoint me. Using the React documentation, it was able to answer my question on how to turn off autocomplete on the input field pretty well. So let's see everything that we'll be covering today. We'll start with LangChain, and this is the framework that helps in developing applications that are powered by language models. This is straight from the documentation, and LangChain is pretty powerful, and our solution is heavily based on using LangChain. Then we'll talk about word embeddings. This topic may need its own video, but in summary, it's just a way to represent words or phrases in a vector form, where the vector just has a bunch of numbers. Now for a given pair of words or given pair of phrases, you can find how related or how similar they are by measuring the distance of these vectors in the vector space. For example, you can just take a dot product and that will give you a single number, and that basically represents how related two words or phrases are. Fortunately, we will not be dealing with any of these numbers, and the libraries we'll be using today abstracts that all away from us. And then we'll ingest a bunch of documents, which basically means creating embeddings that we just talked about. And this will be done using the LangChain framework and the OpenAI embeddings model. So to create embeddings, it needs its own models, and fortunately OpenAI provides one to us, so we'll just be using that. And because we are building a working application, we'll create a few backend APIs, and we'll use ExpressJS for it. The first API will be to ingest documents, and then we'll build an API that can list all the topics which we have ingested the documents for. And then we'll basically start querying on the documents for the related topics. Now we have our ingested data, we have backend APIs, and to surface it to the user, we'll create our frontend using ReactJS. In here, we'll show a list of all the topics that's available to us, and then we'll pick a topic from that list, and then we'll use the chat-like UI to ask questions on that topic and get answers from the documents that we ingested related to that topic. I hope all of that sounds interesting to you. And before we jump into coding, if you have been liking the video so far, please don't forget to like the video and subscribe to my channel. And further, you can show me your support by buying me some coffee or by being a patron at Patreon. You can also have one-on-ones with me where I can help you integrate with ChatGPT in your own application, how to code, interview preparation, any consultations that you'd be interested in, and really anything and everything on any computer science topics. Okay, so let's jump into our IDE and get our hands dirty. Okay, so here I have VS Code, and we have two folders here, backend and frontend. For now, we'll focus on only the backend part. I've created a very bare bones ExpressJS project here, where we have this server.ts file, and we have one API defined, API/hello, which calls this hello method, which is defined in this service.ts file. And all we do here is return a 200 with a JSON of status as hello. Let's use Postman and try to make this API call. So it was a post call, localhost, the server is running at 3000 API and hello, and I don't think I started my server yet, so let me do that quickly. To do that, we can do npm run dev, and this starts the server at port 3000. So going back to Postman and sending this API call, we can see we got the response that we have defined in the service.ts file. I also have this documents folder created here where we have various topics defined. We have 5 topics here, and for each topic, we have this docs folder. So the idea is we'll have the topic folder, and inside the topic folder, we'll have 2 directories. One is docs and the other is index. And in docs, we can have a bunch of files like txt files, markdown files, or even PDF files, and just a mix of them. And they itself can be directories as well. And then we'll index these and we'll save our index in this index folder. For now, we just have this docs folder here. And we can see for cardiac surgery, we have this file here, which is just a bunch of data. And the title for this file was cardiac surgery made ridiculously simple. And I just picked it up from the internet somewhere. Then we have the Ethereum white paper here, which is a PDF file, so we can't open it here. Then we have some data, which I picked from flashcards, where you have a name of a term and a description for it. And then we have a whole React documentation that I pulled from the GitHub repo of react.dev. You have this learn and reference. I just literally copy pasted the documentation. Then we have Wizard of Oz, which is the whole story of Wizard of Oz. Pretty long story here. So we have all of our documents defined here, and we have service.ts that we'll work with. So let's start with something simple. Let's create an API that's called getTopics, which will basically list all the topics that we have here. That is cardiac surgery, Ethereum white paper, medical flashcards, React documentation, and Wizard of Oz. So let's create a new method here. Let's call it getTopics, and I'll copy the request and response from here. And we'll basically be using this import from FS library, and we'll be doing read directory sync, and we'll give it a directory path. Let's define a constant here. Let's call it base directory path, which will basically be directory name, which is our current directory. Then going one directory up from service, we are up, and then we'll go into the documents. And we'll use this in other functions, so it makes sense to define it up here. Next, let's pass it to this redirectory sync. And let's run this through a filter. Let's make sure the directory is actually a directory. So we can do directory.is directory. Not sure why my autocomplete is complaining. Then we could do a map and get the name of the directory, which is directory.name. Cons, we can call it names. I'm just passing an option here. We want with file types, and we'll make it true. Okay, now this is all recognized, and we should have our names. And we can return the name as our API response with a status of 200, and we can basically do a JSON response for it, and we can say response as names. Okay, so our function is defined. Let's wire it up in server.ts. Maybe you can replace this hello with something else. Let's call it topics, and this could be a get API, and we can import get topics from service.ts. Okay, our server has reloaded it. Now let's try to make this API call from Postman and see if it works. So we'll call it topics, make it a get API, and let's send this. And yes, we got our directory list from the documents folder. So that was an easy API. Let's do something more interesting. Now let's try to create a method which can ingest all the documents in a given folder. So we'll create an API, let's call it ingest, and to this API, we'll pass the name of this folder, which you can call as topic, and then it will basically read all the documents in there and ingest the files, that is create embeddings out of it. And then we'll store those embeddings into our file system. So let's see how we can do that. So let's say we get certain parameters from our request. Let's say from the body, we'll make it a post call, which takes in a JSON input, and this can take in directory name as the input. Now, one important thing that we need to set up is the OpenAI API key. You can go to the OpenAI platform and grab the API key, which will allow us to access the OpenAI APIs. And then go into this N folder here, you'll have development.env, and in here, just paste the API key against this environmental variable name. Let's call it OpenAI API key, and you can just paste your key right here. Now to ingest the data, the first thing we need to do is to create an embeddings class. And LangChain provides that. It's called OpenAI Embeddings, just not being recognized here. So I'll just paste the import that I know should be. It's this one. And we've already installed LangChain as the library. And I'll be sharing this whole code base so you can find everything that was required to be installed in package.json here. Anyhow, coming back here, the OpenAI embeddings require an API key. You can either pass it as an environmental variable, or you can pass it here explicitly. I like to do it this way, but please feel free to use the way that suits you. And here we'll just put the same key name that we defined in our env file, so which was OpenAI API key. And this shouldn't be next tick, this should be env. Okay, so this defines our embeddings client to which we can pass a bunch of documents. Now, because we'll be loading a directory, LangChain provides a directory loader, and I'll paste the import for that directory loader here. And then we can simply do const loader equal to new directory loader, and this will take a bunch of arguments. The first argument will be the directory where it needs to read the files from. In our case, that should be the base directory, and to the base directory, we'll add the directory name that was passed to us, which will basically go inside cardiac surgery, Ethereum white paper, and so on. And then all of our documents are inside this docs folder, so we'll put docs in front of it. Then the next thing it needs is how to handle each type of files. So let's say if we have .txt file, what should we do? So to this, you can write path, new, and LangChain provides text loader as one of the file loaders, and I'll add an import for it as well. I'm not sure why the imports aren't working. Maybe my VS Code isn't configured properly right now, but all of this is very well documented in the LangChain documentation. So I will highly recommend to go through the documentation if you're interested to learn about all of these classes that we're using. So that's for the txt file. We'll have two more types. We'll use PDF and then we'll use Markdown. All the React documentation is in Markdown. Then the PDF is for the Ethereum white paper, and everything else is .txt file. Now for PDF, we have PDF loader, and for MD file, we'll keep text loader. If we had used Python library, they have a Markdown loader for it. I read through the code, and behind the scenes, they just used the text loader for the JavaScript library. So text loader should just work fine here. Let me add the import for the PDF loader. And that's all we had to do to initialize our loader, which takes in the base directory, where it should read all the files, and then all the loaders for the individual extensions that we need to handle. Now that we have our loader, the next thing is to load our docs. We'll store them in docs, and we'll do loader.load. Now, just like ChatGPT prompts, where they have a limit how many tokens you can pass, embedding models have similar restrictions. So we can't pass a whole PDF doc or a whole text file to the embeddings. So we'll break it down into smaller chunks. Let's say if you have a text file which has 5,000 characters, then we can chunk them into, let's say, 1,000 tokens each, which will then can be fed into the embeddings model. This is one of the heuristics that you need to play around to see how the document should be divided to get the best results. In our case, we'll just split it as chunks of 1,000 tokens. And to do that, we'll first initialize a text splitter. Let's call it text splitter, and we'll use the recursive character text splitter, and we'll pass it a chunk size of 1,000. I want to double check the import if it's correct, and I don't think this is right. LangChain is going through a lot of development, and a lot of imports are changing, and the JavaScript library is pretty new, so it's still going under a lot of changes. But I knew that this is the right import based on my reading of the documentation. Okay, so let's continue. We have our text splitter defined. Next, we'll take this text splitter and we will split all the documents that we loaded in our previous step, and we'll basically store them in, let's say, split docs. And this is an async function, so we should add an await to it. Okay, so now our docs are split into smaller chunk sizes, which can now be handled by the embeddings. Now to actually create embeddings, we will do it this way. We will use a static method in this class, hnswlib. I can't remember what it stands for exactly, but it's from LangChain again. So let me first add the import for it, and the import for it will be this. And in here we can do from documents, and we give it the split documents that we have. And then we also give this embeddings client that we created. And this is a promise as well. So let's await on it. And then this should give us a vector store. So this vector store will actually be the embeddings that have been created for all of these chunks of the docs that we loaded from our directory. Now that we have our vector store, the next step will be to save it. And for that, we can do vector store.save, and then we give it a directory, and we can use the same path, which is the base directory, then the directory name. And here we can save it in index, and let's just say data. And as a response, instead of saying hello, now we can say done. Okay, so we did a bunch of things here. Let's just go over it really quick before we test this out. So we started by creating an embeddings client, which uses the OpenAI embeddings, and we gave the OpenAI API key to it. Then we created a directory loader, where we gave it a path to the directory where we have all the documents that we need to load. And then we gave it all the individual loaders for each of the file types, which it will use to handle. Then after the loader was initialized, we call the load function to load all the docs from the directory. Next, Because these docs can be pretty huge, we split them into chunk size of 1000, and we did that by calling split documents on the text splitter that we created. Then we ended up with all the split documents here, which was then passed to this hnsw_lib, and then we pass our documents to it and the embeddings model, and that gave us our vector store. And then we just stored our vector store in the same directory, but now instead of docs, we store it inside index data. And then the API simply returns a 200 with the status of done. So let's add this to our API in server.ts. We can simply do a post API here, and let's give ingest as the method name that we created, and we can call it ingest. Okay, so let's go to Postman and try this out. I'll create a duplicate API here so that we can keep our get topics API intact. So changing this to post, making this ingest, and passing in a JSON body, raw, then JSON. And then here we need to pass the directory name, and the directory name is one of these. Let's try with cardiac surgery. So doing cardiac surgery, and let's send this API call. So the API calls can take some time if there are a lot of documents to index, but this one was pretty fast. So going back to our VS Code, now if we expand cardiac surgery, we see there's this new index folder in here. And here there's another folder called data. And then we have 3 different files here, which is basically the index of these documents which we had. So let's see how it looks like. This basically defines the number of dimensions, that is the size of the vector. Then this is just a way on how to find similarity between 2 vectors. Then we have a doc store here, which is a pretty long documentation and some magic, which I don't think we can cover in this video. And then we have this index file, which we cannot open in this text editor. Okay, so we were able to ingest our documents in each of these folders, or at least have the API that has the capability to do that. Let's try to ingest this React documentation. I know this is one of the largest folder I have here because there are just tons of files. So going back to our API and pasting it here as the directory name, and let's send this API call. And this will take some time. It's primarily because it's going through a bunch of files, basically the whole React documentation. And yep, this was done. We can see it took around 24 seconds. So now our data is ingested. Now the next step is to query on this ingested data. So let's see how we can do that. Let's create a new method here. I'll copy this function signature and collapse this. Let's call it query. And let's take some input from our request. Let me do request.body here. And as the input, we can take 2 things. One is the directory name so that we know which topic we are working on, and then the query which the user will pass. Now, the first thing we'll do is initialize our OpenAI client. So we can do model equal to new OpenAI. And to this, we'll pass the OpenAI API key. I'll copy a few more things from here. This is the API key. I'll make the max tokens as max, which you can do by -1, and the temperature as 1. Then we'll also create the embeddings client similar to what we had in the ingest method. So I'll just copy paste it here. And then the first thing we'll do is to load our vector index or our vector store that we stored in our index directory. To do that, we'll get the result back in vector store. We can do the same hnsw_lib dot. It has a load method, and we'll give it the same path which we use when saving it. So copying it and pasting it here. And this is just the path, but it needs a second argument, which is the embeddings, so that it knows what model was used to create these embeddings. Okay, so now we have our vector store, we have the query, and we have our OpenAI model. And by default, I think it uses GPT 3.5 for now. And if you have access to GPT 4, you can provide the model name as part of this initialization. So LangChain provides this another class, which is called retrieval QA chain. And as usual, let me add the import for it up here. And I just noticed that the LangChain import for OpenAI doesn't seem right. So let me fix this as well. Okay, so now resuming our query method down here. Now this is basically a question and answer chain for retrieving answers from your documents. And we initialize it using from LLM method, and we pass the model that we'll be using, which we initialize right here. And then we'll be passing the vector store, which it will use as its source of data, which is this vector store that we pulled from our file system. So we'll do vector store as retriever, and we'll store this in this variable called chain. Now, all we need to do is do chain.call, and we pass the query that the user gave us. And this is a promise call as well. So let's add an await and do response. Now we'll just return this response back using response.status as 200, and the response can be in a JSON response, and we'll continue our pattern of response as response.text. This is where the actual response is from the chain.call, and then we'll trim it in case there's any white space. When I've used this, I've seen it gives you white space sometimes, and this just cleans the output. Okay, so this is our query method, which will connect to our API. But let's just summarize this before we test it out. So first we initialize our GPT model using the OpenAI API key and setting max tokens as the maximum allowed and temperature as 1. Then we created our embeddings client as well, just like before. And then we loaded our vector store from our file system, where we stored it while ingesting the directory. And then we created a new retrieval QA chain from the LLM, and the LLM was model. And then we gave it what vector store to use as the retriever, and all of that combined gives you a chain that we can use to get answers. And then we simply do chain.call and pass a query in, which gives us a response, and the response.text has our actual query response. Again, I'll highly recommend going through the LangChain documentation. There's a lot of concepts like chains, vector stores, embeddings, which will be very helpful to know if you want to build something complex using LangChain and the LLMs. Well, let's wire this query as an API call. We'll go back to our server.ts and we'll create another post API. Let's call it query, and we'll pass query as the method to it. So going back to Postman and duplicating our current API again, and let's do query here. And for the body, we'll keep the directory name and we'll pass query here. Now, because it's React documentation, we can ask a React related question. Let's say, what are hooks? And let's send this API call. So now behind the scenes, it's creating embeddings for what are hooks, and then it cross-references that with the vector store we have and tries to come up with a response. Well, the API call didn't go through because I just noticed that server.ts used the wrong query and it imported query from Express, which is definitely not right. We need query from service. So fixing that and cleaning this up, let's make sure our server restarted. And yes, it's back up and running. Let's try this query again. And yes, we can see our answer here. And React hooks are special functions, and it goes on what hooks are. We can even ask, give me a code example, and we'll try to pull example from the documentation, and we can see it gives you an image gallery functional component where you have this state created. So now we have all our 3 APIs ready. We have the topics, which gives you all the topics available, like Wizard of Oz here. Then we have an ingest API that can ingest any topic that for which we already have the documents for. So let's try to ingest Wizard of Oz. That's ingested. Then we have this query API to which you can pass which topic you want to ask about. And then you put your question. Let's say we ask, who was Dorothy? And when you ask the question, it used the vector store and the embeddings to come up with an answer. And here we can see now it knows what does Dorothy mean. Now for Wizard of Oz, if we ask, what is Ethereum? I'm hoping it wouldn't know the answer because Wizard of Oz does not talk about Ethereum at all. And hence we get the answer, I don't know. So this confirms that it's not using the internet to come up with an answer, and it's limiting the answer to the documents that we know of. So this was all the backend part that we had to do. Now we'll jump onto our front end and build a very simple UI which connects to these APIs and actually showcase the power of it. So let me close these and let's jump into this front end here. I have this front end terminal here. Let me do npm run dev so that our front end starts. This is a NextJS package which I've bootstrapped with a very simple UI. And actually, let's see how the UI looks like. The server is running here. So let's open a server in our browser. You can go here. And this is all we have. It says content comes here, and this is where we'll play. So going back to our VS Code, in here we have this index.tsx page where we have content comes here. And I'm visualizing a UI where we can have all the topics available on the left and the actual chat UI on the right. So we'll create 2 components, conversation and topics. So let's create them here. Let's first do conversation.tsx, and we'll create a corresponding CSS file, which can be module CSS. And we'll also create another file called topics.module.tss, which is the first component that will list all the topics. And we'll create a TSX file for it as well. Okay, so let's start with topics.tsx. So let's do export cons topic, and in here create a functional component, and then we'll use effect. In here we'll try to load all the topics that are available to us. So let's define our API called get data, which will be an async API. and we can use the fetch API to get our response. So we can do raw response equal to await, then fetch, and then the URL for us will be http localhost 3000, and then the API name was API and then topics. Then let's read our response, which will be await raw response dot the JSON response, and then our topics was in response dot response, and we know this is a string array. And let's create a state as well. Let's say topics set topics equal to use state of string array type and initialize it to an empty array. Okay, then before we do anything, let's do a console log of topics to make sure the API call goes through fine. And before we can do that, we need to add topics to our index.tsx. So let's just put it right here. Okay, going back. Oh, looks like I need to return something as well that I forgot. We need to return, let's say, an empty div for now. Empty. Okay, so let's go back to our browser. We can see empty here, which we just added. And let's look at our console. Let me refresh this again. Oh, I need to add the dependency array here and also actually call this getData. Otherwise, of course, nothing will work. So we call getData, and now let's see our response. We can see the API call went through and we got our response in the console. Let me zoom in just a little bit more. Okay, so now let's set these topics, what we got from our API call. And let's also try to render something else other than just empty. Let's call it available topics and have a containing div here, and we can run a for each or a map on these topics. So we can do topics.map, but then the topic, and we can basically return a div where we show the topic as a simple text. So this needs to close. Okay, so let's go back. Oh, we can see all the 5 topics were rendered here, and then we have available topics as our heading. Okay, now the next thing we need to do is to select a topic from this. So we'll have another state. Let's call it selected topic, and let's do set selected topic. This could be string or null, and we'll start with null. Now, when we get our topics, we can add a check here. If selected topic is null, triple check, or if the topics that we got from our response does not include the selected topic, then we need to basically reset it and put selected topic as the first topic. So we can do set selected topic as the first topic that we have. So topics 0. And let's add a flag here so that we know that it was a selected topic. Maybe we can do topic equal to selected topic. We can just say selected, just so that we know things are working. Otherwise, just nothing. Okay, going back, we can see it says selected here, but nothing else works. We can add a simple on click to each other topic clicked, and pass the topic name to it. And simply do topic, and let's declare this topic clicked method will be a simple topic clicked, takes the topic name, and in here we'll simply do the same set selected topic, but this time with this topic name, and this topic will be of type string. So let's going back, let's try if this works. Yep, when we click on them, it changes what's selected. Now let's do one last thing. Every time the topic is changed, we want to convey it to the parent component so that it can pass it to any other child component that needs it. In our case, it will be the conversation component that will require it. So let's add a new prop here. Let's do props, and we can do update selected topic. And to this, we can pass the topic, which is of type string. And this could be a void, and we set topics here. Now anywhere we set our selected topic, that's where we need to update selected topic as well. So we'll actually call it right here, and we'll do props dot update selected topic, and then we'll give the same topic. Let's do the same in topic clicked, and this time this will just be topic, and we should integrate that in index.ts. Now to do that, we'll add a state here. Let's say selected topic, then set selected topic equal to use state, and it will be a string. And for now, let's just give it empty. And then we pass the prop to this topic component, and we can do update selected topic, and we'll take the topic as the input and basically do set selected topic as the topic that we received. Okay, I've said topic enough number of times by now, and let's just render it just to make sure it actually works. Selected topic. So going back to our UI, we can see Ethereum was selected, then medical, Wizard of Oz, cardiac. So this looks good. If I refresh, cardiac surgery should be the one by default, which we can see right here. Some error here. Each child should have a unique key prop. Yes, let's fix that really quick. We can easily do that by adding key, and the key can be the topic itself. And now this warning should go away. Let me refresh, and yes, the warning is gone. So let me add some styles to it just so that it looks just a bit more beautiful. and I'll be right back. Okay, so I think this is pretty decent enough. We added some sizes for the heading. On hover, we have a pointer now, and the background color changes when you click on them. It shows what's selected, and yeah, that's pretty decent. So now let's move on to the next component, which will be the conversation component. So closing topics and coming to conversation. So the first thing we'll do is create our component. So export conversation, and we'll first return a div. And then here, let's say we render our selected topic. So let's take that as props, can be selected topic, can be string, and let's render it right here. And this will be props.selected topic. Okay, let's take conversation and add it to our index.ts. Let's create another div, conversation, and to this we'll pass the prop selected topic, which will be the selected topic from our state. Okay, let's see how this looks. If we have this cardiac surgery here as the selected topic now, change them, it does change. Okay, that looks good. So now the first thing we'll define is how a message looks like. Let's create an interface and a message. The message will basically have a text, so string, and it will have a sender, which will be a user or an AI. Now we'll have a bunch of sections on the UI. First, we'll have, let's say, a header, which will basically say, let's call it conversation history. Then it will have a clear chat button and a button that can call the Ingest API. So let's call it Ingest Docs. Then we can have another div where we can show our messages, and then we can have another div where we can send messages. This looks pretty good. Yep, these should be the three sections. So let's add them one by one. So let's first create a div, which will have conversation history as a title. Then we can create a button with clear chat or as a text for it. And then we can have another button which can ingest the documents. Ingest documents. Okay, let's see. Yeah, this looks good. We just need to have them in one straight row. And then let's create a state that can store all of our messages. Let's say messages, set messages equal to use state, and this can store message array, and we'll initialize it as empty. We can actually even just put some dummy data in here for testing. Let's say text message from AI, and then we can have sender as the AI. Let's do another one for the user, message from user, and let's say sender is the user. Now in the messages, that's where we'll render our messages. So we can do, first let's say, what if the messages are empty? So length, and here we can say send a message to begin. That's just an empty state. There are no messages at all. Then we can add another state where we show when we are waiting for a response. For that, we can have another state. Let's say waiting for response, and we can say thinking. Let's declare waiting for response as a state here. So we can do const waiting for response, set waiting for response, use state. It could be a boolean, and by default it will be false as the initial value. Okay, so now we have the two empty states, or basically one empty state and one thinking state. Well, the next state that we'll add is the messages. So here we can do messages.map. This will be a message, and here we'll return a div, let's say, of the message. Let's just render the message and see how it looks like. Looks like I have a bunch of errors here. Let me fix that really quick. Yeah, this div needs to be a closing div, and that fixes everything. So going back, you can see we have our messages here. Messages from AI, message from user. Yeah, the UI doesn't look good at all, but we'll fix it. Let's add some more divs. Let's say if the message is from AI, we can do message.sender is AI. Then we can render the AI emoji. We can add something similar for the user, and we can add the user emoji. I should wrap this in a parent div. So wrapping it, saving this, and let's see how this looks like. Yep, now this classifies that the message is from AI, hence the AI here, the same for the user. Now let's add the last part, which is the submit button, which is a way to send messages. So we can make this a form actually, and in here, the first thing we'll have is an input, and we can do on change. It can set the user input, just set user input e.target.value. Let's define the set user input as a state up here. So set user input, this becomes user input, and we'll start with an empty string. Okay, and the value should be user input as well for the input box. So let's make this as value equal to user input. Let me break this into multiple lines. I'll also add autocomplete as off, otherwise it just gets annoying. And then we'll add another button which we can use to send the message. And on the form, we can add on submit and call send user message. Let's define that method up here. Let's say const send user message. And in here for now, we'll just console.log the user input. Okay, let's see how this looks like. This looks like a pretty good bare bones UI. Let me quickly beautify this and I'll be right back. Okay, so here we have our chat UI ready. This looks much more refined and clean. Let's try to implement some of the boring functions first, like clear chat. When we click on this, it should take away all of these chat messages. Let's go to our clear chat method, which is right here, up here. Now here, on click, all we need to do is set our messages to be an empty array, and that should do it. So saving this, now trying clear chat, you can see it clear the chat and it put our no messages message here. Then the next thing we need to do is ingest documents. So we can call this as ingest documents. Let's create this method up here. Let's do const ingest documents and we'll do something here. We should do a similar fetch thing that we did in our topics.tss. So I'll just copy some of this into conversation here, and this should be ingest, but this time it'll be a post call. So we'll have to do method as post. We'll be passing some JSON data to it. So headers will be content type as application JSON, and then we also need to pass some body, probably JSON.stringify, and it'll be an object. Now we need to pass our directory name, which will be the selected topic which we had from our props, and this needs to be async. And let's add a state here. Let's say which can track if ingestion was done. So we can do set, or more like ingesting documents, and set ingesting documents boolean, which can start with false. Let's use this one when we call ingesting documents. So we'll set as true. And when we get our response, we can set this as false. Now we don't actually need the responses here at all because we're just ingesting. But down here, when we're ingesting, we can change the name of this. We can do ingesting documents. If we are, then we can say ingesting. Otherwise, we'll make ingest documents as an option. So ingesting documents. And based on this, we can also disable our button. If a document is already being ingested, we shouldn't ingest it again. So we can do disabled equal to ingesting documents. Okay, so let's try this really quick. Let's go to Wizard of Oz and click on ingest documents. It's ingesting, and yes, this comes back to ingest documents. So that worked out. So now the next thing we need to implement is send user message. And in here, we'll again make a post call. So copying all of this here, let's make it async. And the post call will this time go to query, and all of this remains the same. And this time we pass our query as the query as well. And this query should actually be the user input. So it becomes user input, and we don't really need to use this query parameter here. And this will have an event because send user message gets invoked from here on the form. So this will have an event of type react.form event, and it's an HTML form, I think, HTML form element. And then the first thing we'll do is event.prevent default, so it doesn't keep going. And we can actually store our query because we might have to clear it, and then we can update our fetch to actually just use query. Then let's compute our final list of messages, which will be message, and this will be messages. Now, ideally, we would put our latest message after all the messages, but for CSS styling, we are doing it in the reverse order. So we'll put the messages on the top. So this becomes text as the query, and then the message was sent by the user, and adding the missing commas. Oh, and we need an ID as well, which I just added so that we have a unique way of identifying each of the messages. So we'll just use ISO string for that, which will basically timestamp all of our messages. So once we have this, we'll set our messages to this new messages that we created with user's message in here. And then we'll reset the user input to be empty. We also have set waiting for response. That is, if an API call is going through right now to get a response, we'll set that one to true. And the moment fetch is done, we'll set this to false. And we should probably get the response here. So consponse equal to await. Now, once we get our response, we should add that to our final message again. So I'll copy this. And after this here, we can do final messages equal to this ID is good. The text now becomes the response from our API call. So to get that, first we need to do const. This should be, let's say, raw response. And then we'll just copy things from what we did in topics.tsx. And this time the response will basically be a string. So AI response, and put this as the text, and the sender will be AI this time. And once we have this final messages created, we'll set that as our message again. And I think that should be all. It looks like there's an error here. Oh, I forgot to close one of the closing tags. Let's close that here. And let's make sure this works. Yes, it was compiled successfully. So let's try it and see if things work. So I'll refresh this. Let me clear the chat. Let's do cardiac surgery. Let's ingest some documents. And now let's ask a question. How does surgery work? And now it's thinking. And we see we get a whole response, but somehow our user message is gone. So let's see what went wrong there. Okay, so the problem is down here, I think. When we compute our new final message after we get the AI response, we use messages, which does not have the user message. This should basically be final messages. So let's try this again. Let me refresh this and let's clear our chat. Let's try the Ethereum white paper this time. Let's ingest it first because I don't think it's ingested. Now let's ask, what is blockchain? And let's see if it can respond back. And yes, it gives a very nice summary of what a blockchain is. Let's further ask, is Ethereum a blockchain? And yes, it's a very simple answer. Let's go to medical flashcards where we'll have a bunch of flashcards ready. I don't think this is ingested either. So let's first ingest it. And that was pretty fast. Let's see. Give me a new term to learn. And it gives you genome as the new term. What is a genome? And gives you a pretty good summary. Now, what if we say, is genome a plant? Now it should cross-reference and understand what a genome is and if our guess is right or not. So basically says what we thought a genome is actually not right. Let's try React documentation as well. Let's try to ingest it first, which might take some time. Last time it was 24 seconds, so it might take almost the same duration. Okay, let's clear our chat. And now let's ask, what is React? It's thinking, and it gives you a very nice summary. Let's see if we can ask for a code example. Give me an example React code. I think somehow it missed giving the actual React code here. I'm not sure why. Maybe it's trimming on the number of tokens, but anyhow. So let's try this. Let's ask a completely irrelevant question. Who was Dorothy? And the AI clearly says, I don't know, because I'm sure React documentation doesn't talk about Dorothy. And yeah, so here you have it. We have a bunch of available topics here. You can add more topics to your backend, add documents for it, ingest them, and then select your topic here and ask questions on those topics. Okay, so that's all I had for the video. I hope now you realize the power of ChatGPT and how to personalize it to index your own documents and build a whole question and answer framework on those index. If this video was helpful, then please don't forget to like this video and to subscribe to my channel. And you can follow me on Twitter. And please show me your support by buying me some coffee or being a patron. And please feel free to reach out to me if you'd like to have one-on-ones with me. I'm working on the next video, and if you have any suggestions, please don't forget to post them in the comments. Until then, here's another video that you might enjoy. Thank you for joining in. I'll see you next time.